Organic chemistry. Organic chemistry is simply the study of carbon compounds. Remember when we were discussing hydrocarbon, we said that hydrocarbon is an organic compound that contains only hydrogen and the carbon. But if you are dealing precisely with organic chemistry, we are focusing all our attention on carbon. So, organic chemistry is the study of carbon compounds, or the study of carbon purely. That is what we mean by organic chemistry. When we study carbon, we are invariably dealing with organic chemistry. Don't forget that it is not every compound of carbon that is organic. We have some exceptions. A carbon compound like triosocarbonate 4 are not organic. Something like triosocarbonate 4, it is not organic. It is in sharp contrast to the definition now. Remember, we said that organic chemistry is the study of carbon compound. If you watch, this is a carbon compound. But triosocarbonate 4 is not organic. So that definition is an exception to this. Also, we have another one like the oxides of carbon, like carbon 4 oxide, carbon 2 oxide. All these ones are not organic, even though they are carbon compounds, but they are not organic. I hope all these things are clear. Another one is metallic sulfides of carbon or carbon sulfide. Sulfides of carbon, such as carbon 4 sulfide, is not organic as well. So, with these exceptions now, every other compound containing carbon is considered organic. So, if we are dealing with triosocarbonate 4 sulfide, oxides of carbon, those ones are not organic. They are not under organic chemistry. But every other one, like ethane, methane, alkanols, all the rest of them that has carbon, are grouped under what? Organic chemistry. Now, let us see the valency of carbon and also why carbon forms so many compounds. Because if you can see, carbon has so many compounds. Let us see the structure and the valency of carbon. If you watch, carbon is 6, that is the atomic number of carbon is 6 in the periodic table, and its ground state electronic structure is 1s2, 2s2, 2p2. That is the ground state electronic structure of carbon. But in the excited state, you have something like this: 1s2, 2s1, 2px1, 2py1, and 2pz1. This is the excited state electronic configuration of carbon. And from this, it then means that carbon is ready to accept 4 bonds from any other element for it to maintain bond stability. If you want, this one is not complete, this is not complete, this is not complete, this is not complete. This one is supposed to be 2, 2, 2, but they are 1, 1, 1 now. That is why the valency of carbon is 4, meaning that it can accept to go into bonding with 4 different elements. And that is why the structure of carbon is always tetrahedral in arrangement. Tetrahedral, because of the 4 valency of carbon, is always tetrahedral in arrangement, such as this. And that is why the bond angle, this is a tetrahedral arrangement of carbon. And that is why the bond angle, that is angle between one bond and the other bond of carbon, is 109 9 degrees 28 minutes. 28 seconds. So that is why the bond angle is like this. Because of the tetrahedral arrangement of carbon. And that tetrahedral arrangement of carbon is as a result of the four valency of carbon. So the structure of carbon is like this. It is tetrahedrally arranged. And the bond angle is 109 degree 28 seconds. So that is the bond angle of carbon. Now let us see why carbon form numerous organic compounds in a subheading I termed apparent uniqueness of carbon. Why carbon form numerous organic compounds, I term it apparent uniqueness of carbon. Carbon has the ability to form ring compound. It has the ability to form straight chain and highly branched compounds. And that is the term we call catenation. Catenation. Which is the ability of a carbon to form straight chain, ring compound, and highly branched compounds. It is not as if other elements like silicon don't have that ability. But in contrast to carbon, if silicon should form straight chain compound, the longer the chain or the longer the bond of silicon, the weaker it is. But carbon can form very long straight chain, branch chain without weakening the bond. And the bond will still be as strong as when it is bonding to two. But silicon, as long as in fact, it cannot bond more than 20, 30, it will become weak. The bond will become weak. So that is why it is only carbon that has that ability to form both straight, highly branched, and the ring compound. We term it catenation. Remember, we are discussing why carbon form numerous organic compounds. I charge you today, even if you've gone to the pharmacy to buy drugs, try to bring out the leaflet inside that drug report. Check the component. You see that most of the component of that drug is organic compounds. And even the structure they may draw there, you cannot interpret it. So carbon forms so many organic compounds. You may ask, why are we focusing our attention on carbon? It's because we are dealing with organic chemistry. Organic chemistry studies carbon compound or studies carbon solely. So another reason why carbon forms so many organic compounds is carbon has the ability to combine with other elements. Carbon can bond with sulfur. Carbon can bond with oxygen. Carbon can bond with chlorine. Carbon can bond with bromine and so many other compounds. Unlike other elements, they may not have that ability to bond with all these elements I have mentioned and more. But carbon can comfortably bond with chlorine and so many other elements. Remember, why do we have so many organic compounds? Another reason is that carbon has the ability to form single bond, double bond, and the triple covalent bond. Just as you saw on homologous series, where we drew a single carbon, a single bond carbon, and the double and all the rest of them, which we will deal subsequently. So carbon has that ability to form carbon to carbon single bond, carbon to carbon double bond, and carbon to carbon triple bond. That is the reasons why we have so many organic compounds. Apparent uniqueness of carbon.